Hey everyone! In today's lesson we're going to talk about factoring complex trinomials, just with a few more difficult questions. Once you have factoring as a concept down pat, this should be rather easy for you. We're just going to do some practice so that you get used to it. Let's do our first example here. We are asked to factor fully 2x to the power of 4 plus 9x squared plus 10. The difference with this and a typical trinomial problem is the fact that I have the 4 and a squared instead of a typical x. However, it follows the exact same pattern. I have 3 coefficients, my last one doesn't have any x value with it, so we can follow the exact same steps to factoring. I'm going to draw my x over to the side here, multiply and add. We need to add to 9 and multiply to 20. In this case, the two numbers are 4 and 5. I'm going to follow the exact same strategy of decomposition here. 2x to the 4 plus 4x squared plus 5x squared plus 10. Recall, we're splitting up our middle term into these two parts. That's why I have an x squared attached to my 4 and an x squared attached to my 5. Not just x and y, they need to be x squared. They need to match the variable in the middle. I'm going to common factor my first two terms here. I can pull out a 2, and I can also pull out x squared. That leaves me with an x squared and a 2. In my second pair here, I can pull out a 5, leaving me with x squared, once again, plus 2. Okay, I common factor, I have x squared plus 2, 2x squared plus 5. We can confirm at a glance that when I expand, I'm going to be left with x to the 4 because I have an x squared and an x squared. Those multiplied together will give me x to the power of 4. You could have also just thought, let's just treat it as an x and go about our way, and it's actually half of what's left over, what's in our first term here. Either or, decomposition probably works the best for you because that's what we've been doing for all of these problems. Another trickier question here, 5x squared minus 12xy minus 9y squared. Again, we're going to treat this problem as if there are no y's present, just for now. I need two numbers that multiply to negative 45 and add to negative 12. In this case, the numbers are negative 15 and positive 3. Let's go ahead and decompose here. 5x squared minus 15xy plus 3xy minus 9y squared. I can pull out a 5x for my first two terms, leaving me with an x and a negative 3y. In my second pair, I can only really pull out, I can pull a 3 and I can pull a y, again leaving me with x minus 3y. Go ahead and common factor here, x minus 3y times 5x plus 3y. A third example, this time it's more challenging because I have an x minus 3 in my brackets here. We're going to treat x minus 3 as our variable, and we're going to go about this in the exact same way, decomposition. I'm going to draw my x. I need two numbers that multiply to negative 20 and add to negative 19. Those numbers are negative 20 and 1. Let's go ahead and decompose here. 4 x minus 3 squared minus 20 x minus 3 plus x minus 3 minus 5. Let's go ahead and common factor our first two terms. I can pull a 4, and I can pull an x minus 3. That leaves me with x minus 3 minus 5. Because 20x minus 3 divided by 4x minus 3, well, the x minus 3's will cancel out. I'm left with negative 20 divided by 4, which is negative 5. There's nothing in common between these two terms. So I'm just going to factor out a 1. And I'm left with x minus 3 minus 5. Let's go ahead and simplify here. X minus 3 minus 5, x minus 3 minus 5 can be simplified into x minus 8. Negative 3 minus 5 is negative 8. And we can common factor out an x minus 8 from these two terms, leaving me with x minus 8 times 4 x minus 3 plus 1. I can expand my second bracket here to give me 4x minus 12 minus 1, which is 4x minus 13. So the factored form of all of this is x minus 8, 4x minus 13. Now if you're saying to yourself, I have no idea what she just did, literally no idea, I did not follow this, that's okay. There's more than one way to handle this type of question. I'm going to do it on a whiteboard. Four times x minus 3 squared minus 19x minus 3 minus 5. What I'm going to do is I'm going to replace x minus 3 with a new variable. In this case, I'm going to let it be a. A is going to be x minus 3. I can then rewrite my original problem as 4a squared minus 19a minus 5. This is a problem that is very easily factored. I draw my x. We needed to add to negative 19, multiply to negative 20. We've already said the numbers are negative 20 and 1. I can go ahead and I can decompose. I group factor my first two terms. I can pull out a 4a from both of them, leaving me with a minus 5. And my second pair here has nothing in common, so I can just do a 1, a minus 5. I factor out my a minus 5, and I'm left with 4a plus 1. Well, our original problem did not have an a in it. Our original problem had an x. We need to return to our original state, our original variables. X minus 3 was in lieu of a. So I'm going to go ahead and I'm going to replace my a's with x minus 3. That gives me the problem x minus 3 minus 5 times 4x minus 3 plus 1. Now this is starting to look familiar with where we landed last time. X minus 3 minus 5 is x minus 8. I go ahead and expand my second bracket here. 4 times x is 4x. 4 times negative 3 is negative 12. All plus 1. I simplify that to be 4x minus 11. Exact same problem, or exact same answer as if you had done it previously. Okay, quick typo to fix here. It looks like my +1 became a -1, so my answer should be that. Okay, and last example, the area of a rectangle is 10x squared minus 3x minus 4. Determine the dimensions if x is equal to 2 centimeters. Well, you recall that area is length times width, so I need two terms multiplied by each other to give me the binomial expression that represent my rectangle dimensions. In order to get those binomial expressions, I need to factor my area. So I need to factor 10x squared minus 3x minus 4. Well, I'm looking for two numbers that multiply to -40 and two numbers that add to -3. Those two numbers are going to be -8 and +5. I go ahead and decompose this. 10x squared minus 8x plus 5x minus 4. Factor my first two terms, I can pull out a 2x, leaving me with 5x minus 4, plus a 1, 5x minus 4. I factor again, 5x minus 4, and I'm left with 2x plus 1. So let's say that my length is equal to 5x minus 4, and my width, actually I'm going to write width over here, is 2x plus 1. Well, we were told in the question that x is equal to 2 centimeters. So let's find our actual length and our actual width. I'm going to substitute 2 for x for both my length and my width. I can then go ahead and calculate. 5 times 2 is 10, minus 4 is 6. 2 times 2 is 4, plus 1 is 5. So I can have a conclusion over here, therefore statement, therefore the length is 6 centimeters and the width is 2 centimeters. And that's that.